Good morning, everyone. In the previous lesson, we learned about pipe dimensions such as outside diameter, inside diameter, and nominal pipe size. Now let's focus on another critical parameter, pipe wall thickness. Wall thickness is one of the most important design factors in any piping system. It determines how much pressure a pipe can safely withstand while maintaining its structural integrity. A thicker wall generally increases the pipe's pressure rating and mechanical strength. However, it also reduces the inside diameter, making less space available for fluid flow. In addition, increasing wall thickness means using more material, which results in greater weight and higher manufacturing costs. Engineers must also consider corrosion allowance by adding extra wall thickness to compensate for material loss during the service life of the pipe. Selecting the correct wall thickness is always a balance between safety, performance, and economy. Three methods of specifying pipe wall thickness. Throughout the history of piping engineering, three different methods have been used to specify pipe wall thickness. The earliest method was the weight class system, which classified pipes as standard weight, extra strong, and double extra strong, commonly abbreviated as STD, XS, and XXS. As piping systems became more complex, the industry needed a more accurate and standardized method. This led to the introduction of the pipe schedule system, which is now defined by ASME standards. Today, a schedule number such as Schedule 10, Schedule 40, and Schedule 80 are the most common way of specifying wall thickness worldwide. Finally, engineers often use the actual decimal wall thickness, expressed in inches or millimeters, for design calculations, inspections, manufacturing, and procurement. Although all three systems are still encountered in engineering practice, the schedule system has become the international standard. Understanding pipe schedule numbers. Now let's take a closer look at the pipe schedule system. One common misunderstanding is that a schedule number represents the actual wall thickness. In reality, a schedule number is only a standardized designation defined by ASME B36.10M for carbon steel pipes and ASME P36.19M for stainless steel pipes. For a given nominal pipe size, the outside diameter always remains constant. When the schedule number increases, the wall becomes thicker, which causes the inside diameter to become smaller. For example, a 4-inch Schedule 80 pipe has the same outside diameter as a 4-inch Schedule 40 pipe, but its thicker wall reduces the available flow area. Because every manufacturer follows the same standards, schedule numbers ensure complete compatibility between pipes, fitting, flanges, and valves. Equivalent thickness designation. Let's compare the historical weight classes with modern schedule numbers. For many common pipe size, standard weight or STD is approximately equivalent to Schedule 40. Similarly, extra strong or XS is generally equivalent to Schedule 80 for a smaller nominal pipe size. Double extra strong or XXS designation is more complicated. For some pipe sizes, it's close to Schedule 160, while for larger sizes, it can actually exceed Schedule 160. This is why engineers should never assume that weight classes and schedule numbers are always interchangeable. Instead, the correct equivalent must always be verified using the ASME P36.10M tables. Finally, notice the decimal values shown at the bottom of the slide. These numbers represent the actual measured wall thickness and are the values used in engineering calculations, inspections, and fabrication. Let's summarize today's lesson. Pipes wall thickness can be specified using three methods: weight classes, schedule numbers, and actual decimal thickness. Weight classes such as STD, XS, and XXS are historically designations that are still found in many older drawings and specifications. Schedule numbers are now the internationally accepted standard because they provide consistency across manufacturers and industries. Actual decimal thickness represents the real physical wall thickness and is essential for engineering calculations and quality inspections. Remember that increasing wall thickness improves pressure resistance but reduces the inside diameter and increases both weight and cost. Understanding these concepts is essential before studying pressure design, fittings, flanges, valves, and piping codes. Thank you for your attention, and I will see you in next lesson. The next lesson is about pipe selection. Please subscribe, likes, and enjoy our concepts.